Share was fun.
Yeah.
Yeah.
You seem to have frozen. There we go. All right, we'll get started. Thanks everyone for coming. This is a great turnout. And we've got quite a few people online too, which is fantastic. Welcome to our second seminar of the semester. Before, I'm not going to be doing too much today, but I will just start us off by just doing an acknowledgement of country. So we acknowledge the traditional custodians of the unceded lands on which we're all meeting today. For us here on campus, it's the lands of the Ngunnawal and Ngambri peoples. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connection to country. We acknowledge the significant contribution that they have made and continue to make in caring for this land and sharing their knowledge and culture. And we also acknowledge and welcome any Aboriginal and Torres Strait Islander peoples who are joining us today in the room or online. So I'm going to hand over now to Steph to introduce our wonderful speaker. Over to you, Steph.
Great. So Nick began his, or Nicholas White, but to many of us Nick, began his PhD in 2021, but he really joined the lab much earlier. So I ran a special topics course, which is like a research masterclass where I handpicked top performing students from the cognition course. Nick was amongst those to do this course. And even amongst that super high performing cohort, Nick really stood out to me. So I hired him as a research assistant on my future fellowship grant for a few years. Nick started his honours then under my supervision in 2020. Great year to be doing honours. And then he won the thesis prize for the best thesis mark in psychology. So going on to a little wow people. And then he started his PhD in 2021. So during his candidature, he's done some really important fundamental research about attention and how we conceptualize and measure it and its implications for human functioning more broadly. He's published his work in field-leading journals like Attention, Perception and Psychophysics, including having a bunch more under review and revisions under review, so watch this space. Nick's also a great departmental citizen, so I'm sure many of you know of him in that context, readily puts his hand up to organise student events, mentor other students, and just generally all-round helpful person. Nick's supervisory panel for the PhD consists of myself, Assistant Professor Mark Edwards, and Dr. Bradley Jack. And I know I speak on behalf of all of us when I say what a pleasure it has been to supervise you. It's really a rewarding part of an academic's life to work with students that are smart, motivated, talented, and that we learn from as much as we guide you. So for those of you who don't know, Nick is on an academic pathway. I think he's going to be a brilliant academic with an illustrious career ahead.
Okay.
The next step on that pathway is a postdoc position. So for those of you who don't know, that's a sort of research intensive period where you work usually in a different labs where you've done your PhD. Those jobs are super sought after and highly competitive. Nick aced his first interview and got a job offer from that and accepted that. So he's going to be starting a postdoc with Professor Mark Lapelli at the UNSW in June. So now just the minor task of finishing the so on that note, enough from me. Let's get started so you can hear about all the fabulous stuff Nick's been doing.
Well, firstly, thank you to Steph for those beautiful words. I'm quite emotional now. So let's see if we can give a presentation that lives up to all of that hype. But no, sincerely, I would not have had it any other way. I've loved my journey up through the ranks and my time here at ANU working with you, Steph, Mark, and Brad. So thank you so much from the bottom of my heart. I hope to do you proud. All right, so today we're here for my final oral thesis presentation, and I'm going to be talking about deployments of spatial attention, how we measure them, how we conceptualize them. I want to give you a bit of a roadmap for this presentation before we get into it. So firstly, I'm going to tell you about the rationale and objectives for this thesis. Secondly, I'm going to tell you about the first topic that's comprised of research interest for me during my studies here, which is attentional breadth. And thirdly, we'll talk about the studies that I've done with respect to this topic. Then my thesis kind of takes a slight topical change. It goes broader and we look at the different ways that we deploy spatial attention. So I'll introduce you to some fundamental concepts here. Then we'll review the studies that we conducted on this topic space. And finally, we will leave off with some conclusions, future directions, and musings on this experience. So first up, let's talk about what we set out to achieve with this thesis. To do that, we need to understand what I mean when I say deployments of spatial attention. So when I use this term, and it does feature frequently in this presentation, I mean how we change our allocation of spatial attention across time, which is how we determine which visual information in the world around us is subject to higher order cognitive processing. So this is something that we're doing all the time if we have the sense of sight, and you can see this at work here in this little snippet to the right, or left, I guess, where we see this in action during driving. So in this sort of central circle, we have someone extracting information from a relatively small region of their visual field. Perhaps they're looking for a park in that space up ahead, or they're following the movement of the cars up ahead. However, you could also use a slightly broader breadth of attention here, in which you would be monitoring that car, which might try and turn onto the road in front of you. So with that in mind, we broadly class that as being two kinds of spatial attentional deployment. Now, we'll start with the less intuitive one of these, which is attentional breadth. And attentional breadth is the sub-region of the visual field from which we are prioritizing the processing of information. And we know that attentional breadth can vary in size. So again, to sort of follow through with this analogy, imagine you're just driving down the road there. If you want to maintain concentration on where the road is headed, you might use a relatively small breadth of attention, which is that space in the red. But if you wanted to monitor your instrument cluster and the GPS without breaking your line of sight from the road, you might use a larger attentional breadth that also encompasses this information. The other is kind of a bit more intuitive. It's shifting our attention. And this is where we reorient the point of visual fixation. So this can definitely happen covertly in the absence of eye movements, but the classic way that we change where we are deploying attention is by changing where our eyes are looking, or what we call eye movements. So this is a very basic primer on a very complicated field, but the reason that we were interested in the deployment of spatial attention during this thesis was twofold. So spatial deployments of attention are so important to the study of visual cognition because they're so important to daily life. You know, if you have the sense of sight, you are using it constantly, you are filtering information from the world around you. It's informing your experience of that world, your percept of that world. It connects with things like emotion and, you know, executive function. Basically, it is so integrated into our concept of the world around us. However, there are some really core questions in this topic space of spatial deployments of attention which remain uninvestigated. So the first rationale for this thesis was trying to revisit some foundational but untested assumptions that underpin research in this topic space. The other one was trying to clarify the relationships that exist between different kinds of spatial attentional deployment, about which we knew very little before this thesis. So that leads us to two overarching research questions. One is how we conceptualize and measure deployments of spatial attention, and the other is how different kinds of spatial attentional deployment relate to each other. And these form the two parts of my thesis. So let's move on then and tackle attentional breadth, which is our first topic area, and it gets to the heart of this idea of conceptualizing and measuring spatial deployment of attention. So what do we know about attentional breadth? Well, we have some good starting points here. One of these is what we call the zoom lens model. In simple terms, it's this idea that there's an inverse relationship between the size of the region we're attending to and perceptual acuity. So that wasn't simple terms at all. Let's look at a picture to try and understand that a bit better. So when we're using a small attentional breadth, like you see on the left here, imagine that we're focusing in on the face of this little sheep. Now, this is a fairly small attended region, but you can see that we have quite good perceptual acuity. In other words, we're perceiving the fine detail of that sheep's face pretty well. However, on the right, you can see that someone has expanded their breadth of attention. In this example, they are attending to a larger region of the visual field, which still centers on that same spot, the sheep's face, but they have lost perceptual acuity. Their percept of the scene is degraded and they're not seeing it as clearly. Now, another thing we know about attentional breadth is that it can be static or dynamic. So when we use attentional breadth statically, we're sort of viewing one point in space, we're adopting and maintaining breadth of attention. However, we can also use attentional breadth dynamically, which is probably a bit more common, where we're resizing the attended region in response to new stimulus information. So all I mean by that is we are changing the physical size of the region in space to which we are attending, probably on a chronic and continuous basis. And what we also know about attentional breadth is that it's not a very sort of well-known construct. I don't think it's something we necessarily think about a lot in daily life, but it has a range of relationships with other psychological variables. So to give you some examples here, there are lots of state or trait variables that influence the breadth of attention we're using. And these are things like motivational state, mood, working memory load, personality, age, and working memory capacity. But we also know that attentional breadth, adopting different ones, has pretty dramatic perceptual and cognitive consequences. So as we've discussed with the zoom lens model, one of these is spatial acuity. However, there are also a whole bunch of others. We know that temporal acuity is affected, our ability to tell apart fine detail of things that happen in a time course. So that involves things like change detection. We also know that different attentional breadths have consequences for our ability to see faces or process things in ensemble. It even affects our ability to sort of detect different emotional expressions, and it affects our susceptibility to attentional capture. So what don't we know about attentional breadth? Well, there is a really major problem that casts quite a long shadow over this field, and that is how we measure attentional breadth. So this is not a particularly glamorous problem. It's not one that sounds super exciting to talk about, but it has some really important consequences. The idea at the heart of this problem is that many different tasks are claimed to gauge attentional breadth, and people create new measures of it all the time. It's kind of like the Wild West of cognitive science. However, these tasks are rarely validated as measures of attentional breadth. So really all the seal of approval they need, even in the peer review process, is for an author to make a convincing claim or observation that their task measures attentional breadth. They don't need to offer evidence of this. For those of you from fields of psychology outside of cognition, this is probably a pretty dramatic departure from the kind of thing that you're required to do if you want to use a new measurement scale or whatever. Only one task in the whole literature on attentional breadth has been well validated as a measure by converging neural correlates evidence, and this is our Navon paradigm. Now, if you did your undergraduate at ANU, you've almost certainly seen this one in different experiments. Basically, it uses what we call composite letters, which are big capital letters made up of the shape of a different smaller capital letter that's repeated to form it. The idea behind a Navon figure is that you can view it at one of two levels of detail. Either you're attending to the small repeated letter, which entails the use of a smaller attentional breadth so that you have the perceptual acuity to perceive that. Or you can view that large overall shape whereby you need the large attentional breadth to identify the shape of the figure. And here's just a little snapshot of what that neural correlates evidence actually looks like. This is an fMRI. You can see what happens when people look at the local components of a Navon figure in blue there. They have a very limited region of activation, but it's quite intense, so they have good perceptual acuity. On the other hand, the region in orange is what happens when they view the overall shape. You can see that it's physically larger, but it has much less extent of activation. Therefore, people have lost perceptual acuity when they view that overall form. So what are some of the potential consequences of failing to validate our measures of attentional breadth? Well, one of them is method variance. So we have no proof about whether performance on all these different measures, and they do vary pretty dramatically, actually reflects an identical construct. The second problem is how attentional breadth relates to other factors. So if we haven't validly measured attentional breadth as our construct of interest, the conclusions we make about how it relates to other factors or other tasks or other cognitive processes may be called into question. So these two problems are what my thesis set out to address in its first part, and we'll tackle them in turn now, moving on to studies 1 and 2, measurement of attentional breadth. So firstly, we wanted to tackle this problem of method variance, where we try and do some exploratory work to confirm whether different measures of attentional breadth actually reflect the same construct. And in our first study, we were really trying to get at this research question through a methodology of inducing different attentional breadths using one task and seeing how it affected performance on a different task. So a neat function of Navon figures, not only are they validated as measures of attentional breadth, but if you get someone to respond to a Navon figure where they're looking at either the local or the global level over and over and over again, that actually induces the attentional breadth necessary to complete that task. Now, you can imagine this is not the most exciting procedure in the world for the participant, but it's one of those studies where we just have to do it over and over again to get a good idea of induction. So once we've induced attentional breadth using this procedure, and say we get them to do this on 80% of trials, which are randomly mixed together, we then throw in a 20% of trials with a different measure which has been claimed to gauge attentional breadth, which is our Ericsson flanker task. So I'll give you a brief graphic here of what that looks like. In the middle, we have our classic Navon figure, and at the top and bottom, we have two sample trials of an Ericsson flanker task. Now, the idea behind this one is that you are attempting to identify the central of those three letters as either H or T, say. And this normally is pretty easy when all the letters are the same, which is what we call the congruent condition, as you see at the top. However, it becomes significantly more challenging in the incongruent condition, which you see an example of at the bottom there. So this is claimed to measure attentional breadth because there should be a point in space at which those flankers no longer interfere with task performance. You can imagine when they're really closely bunched up together, like in that top example, they might have quite an impact. Whereas in the bottom example, as we start to increase the spacing between the central figure and the flanker, it might exert a diminished influence on task performance. So what did we find when we got to inducing attentional breadths with Navon figures, and then we got people to do the flanker task? Basically, we were looking for this interaction effect. We needed attentional breadth induction, either big or small, to interact with the flanker congruency effect. So congruent versus incongruent trials. Now, if our distractors were not falling within the attended region, then using a smaller breadth of attention should reduce the magnitude of the flanker effect, which is the difference between congruent and incongruent trials. And here's what we actually saw across two experiments. So there was a main effect of flanker congruency, which is great. That showed us the task worked as expected, which was kind of necessary. We saw a main effect of attentional breadth induction, where performance was faster overall when people used a smaller breadth of attention. So we know that our induction did something, and it was in the sort of direction that we would expect. However, there was zero interaction between congruency and attentional breadth induction. Basically, this tells us that attentional breadth doesn't really influence the magnitude of the flanker congruency effect. Therefore, it calls into question the use of the flanker task as a measure of attentional breadth. Basically, using a smaller attentional breadth helps task performance, but the task itself is not a good measure of attentional breadth, which is a pretty striking finding in a literature which regularly uses this task to measure that construct. Instead, we think that the flanker task is more likely to reflect processes related to response inhibition and selection, so figuring out what the actual target is in competition with those sort of distractors, which is much better validated by neural correlates evidence than the attentional breadth explanation of task performance. Okay, so our first problem, method variance, has been borne out by our observations in studies 1. What happened in study 2, where we took this knowledge and tested how attentional breadth was associated with other factors, not flankers. So in study 2, we went back and revisited some previous research which had been done about the relationship between attentional breadth and the UFOV task. Now, this has nothing to do with UFOs. The UFOV task is measuring a construct which we call the useful field of view. It's basically the region of your visual field which you can actively process information from in quite a constrained time span. It's an incredibly useful real-world measure of crash risk in older adults, and we know that it draws upon many different cognitive processes. However, one cognitive process which has previously been dismissed as associated with UFOV task performance is attentional breadth. And this dismissal was performed on the basis of research which used the flanker task to measure attentional breadth. Now, in light of our findings from the previous study, that is a bit of a problem, and potentially this role of attentional breadth as a correlate of task performance has been overlooked. So what did we do in this study? This is one of those lovely studies which is not too conceptually difficult to understand. We wanted to see if people's ability to resize their attentional breadth, so to sort of change the area from which they're getting visual information, relates to UFOV task performance. And here's a little infographic about what that might potentially look like. So UFOV has different subtasks. In these top two images here, A and B, you see how resizing might be implicated in subtask 2. Basically, people have to identify that little central icon as either a car or a truck, while simultaneously identifying the location of a peripheral distractor. We thought maybe people start off using a big breadth of attention, then they come in small to have the perceptual acuity to identify that central target. On the other hand, we thought they might change strategy for subtask 3, where there are now a bunch of distractors in the scene when you're doing the exact same 2 tasks simultaneously. Given that suddenly this scene is very cluttered, we thought people might start with a small breadth of attention to exclude that distracting information and identify the central target, then expand out big and try and pick out where that peripheral target is located. And what did we end up observing? Well, exactly that. So basically, we saw that subtask 2 of UFOB related to people's ability to contract their attentional breadth efficiently, while subtask 3 performance related to the ability to expand attentional breadth efficiently. So this was a nice sort of proof of concept study. It showed us that the role of attentional breadth in other task procedures or its relations to other factors may have been prematurely dismissed, not because there's in fact an absence of relationship between these 2 constructs, but instead because there have been issues with how we operationalize or measure attentional breadth in previous research. So what did we learn from this first part of the PhD? Well, I want to offer a few key takeaways. One of these is that, particularly in the field of cognition, we need to learn from other areas of psychology in validating our operationalizations of constructs. This is true even when those operationalizations have really quite long-standing histories of use. So the flanker task originally comes from the 1970s and has been continuously used as a measure of attentional breadth since that point. We also learned that attentional breadth is a multifaceted construct. So it's not just your ability to maintain a certain size, but instead your ability to resize and work with it dynamically in response to task demands. Given that we use and modulate attentional breadth in so many ways, we think that it's really important that you actually consider what kinds of attentional breadth modulation are likely to be implicated in other task performances or other processes to get the best chance of detecting relationship with other constructs there. So this first part of the thesis was quite technical. It investigated questions which really get my heart racing, they maybe get Steph's heart racing, but maybe to a room of people, they're not the most compelling, eye-opening stuff. In moving into the second topic of our thesis, we tried to investigate some questions that have clearer real-world implications. We looked at the different ways that people deploy spatial attention and how these different kinds of spatial attentional deployment relate to each other. So the reason that we moved into this stage of research during the thesis is because we have this desire to look beyond the construct of attentional breadth. So this is clearly a really useful and relevant construct, and it defines a lot of the way we interact with the world around us, but it has one really obvious problem when you reflect on it, and that is attentional breadth struggles to account for eye movements, which are the main way that we actually deploy spatial attention and get information from the visual world. So because attentional breadth measurement is largely contingent on maintaining your focus on a point in space and seeing how breadth varies around that, it really is not very flexible for the measurement of eye movements. However, virtually nothing is known about the relationship between how we use attentional breadth and how we behave using eye movements, which led us to the second part of this thesis. Are there overarching consistencies in how attentional breadth and eye movements are deployed at group and individual levels? So one thing that we need to mention at this point as well relates to how we measure eye movement behavior. Now, I know a few people in this room participated in my research, so you have sort of a privileged glimpse into this world. When we measure eye movement behavior, we do so using equipment called an eye tracker, which is a camera that sits on the desk and measures where you're looking on the computer screen while you complete tasks of interest. Now, that's all very well and good, but when we try and measure people's ability on different cognitive tasks, often we get very similar patterns of eye movement performance. So imagine that you're doing a task like memorizing objects or looking for something in a visual scene, what we call search. You can imagine that the most efficient strategy, the most optimal strategy is pretty obvious to people here, and therefore that you'll get very similar patterns of eye movements across people. So in moving into this part of the thesis, we wanted to distinguish between people's ability to deploy eye movements in response to task demands and how people prefer to use eye movements in circumstances where that sort of strategy or optimization element is not so salient. In other words, we wanted to study people's preference behavior. Now, we think that this is important as a line of research because of ecological validity. It much better sort of accesses what we do, not when we're completing a specific task, but when we're just behaving in daily life without any clear agenda. So for studies 3 and 4, we were studying preference behavior through this paradigm that we created where there's no clear optimum strategy. Basically, what people did is that they viewed a series of nature images under instructions that their memory would be tested for these pictures later. Instead, we didn't really care about their memory test performance. That was a slight bit of deception. We were interested in how they viewed these images when they were given the freedom just to look at them. And here are some examples of the kind of picture that they might have expected to see. They're relatively complex. There's not necessarily a clear focal subject. We were able to confirm through linear mixed modeling later on that the differences between these images really did not contribute much to task performance here. Okay, so there are also a few key metrics of eye movement behavior that we should talk about at this stage. One of them is saccade amplitude. So it's how far we move our eyes every time that we make an eye movement. And then scan path length, which is kind of a summative approach to that. It asks how far do we move our eyes over a period of interest. We then have fixation duration, which is how long we hold our gaze at a certain point. And you can imagine that that varies based on information in the scene and also based on individual preference. Finally, as a sort of analog to attentional breadth, we have exploratory breadth. How far out from the center of the image people made its fixation, basically how engaged they were with the information in the visual scene. And that brings us now to talking about the last two studies of the thesis, where we used our preference measure of eye movement behavior to see how this aligned with attentional breadth behavior. So first, we wanted to look at this in group level behavior. We wanted to see how attentional breadth and eye movement behaviors were affected by an experimental manipulation, whether there were consistencies in the sort of changes that they underwent based on this manipulation. And the manipulation we chose to perform for this study is working memory load. Now, you may remember that attentional breadth is known to change based on working memory load. So we wanted to see what would happen when we got people to complete these tasks. The reason that working memory load is of such interest to studies of attention is because it subserves our ability to allocate spatial attention efficiently. As working memory load increases, our ability to deploy attention selectively is impaired, and processes which are dependent on attentional control or executive function become less efficient. You can see this when you imagine driving the car again. Every cognitive scientist's favorite example is driving. Basically, if you're just driving down a nice empty country road, it's sort of a low load situation. You might be monitoring for dangers, but there aren't a lot of distractors in the visual environment. Now imagine it's school rush hour, you're picking up your kids, they're having a fight in the back seat, you're trying to turn the music up to drown them out, there's a million different cars cutting in ahead of you. Suddenly, that use of attention that you need for driving becomes a lot harder. So we wanted to know how different kinds of spatial attentional deployment are affected by working memory load within the same sample to see if there are sort of overarching consistencies here. And basically what we did, we got them to complete that measure of eye movement behavior that I've described, as well as a measure of attentional breadth under low and high working memory loads. And we saw that increasing working memory load had this interesting impact on eye movement behavior, where it clearly became more effortful for participants to move their eyes, but their behavior was a lot more erratic when they undertook eye movements. Interestingly, this finding was not observed for attentional breadth in our sample. But the finding that really blew us away was individual differences based. So what we saw completely unexpectedly were these striking individual differences in eye movement behavior, which were really strongly correlated across working memory levels. And this is particularly amazing because we would not necessarily expect these individual differences to be so robust that they survive a working memory load manipulation, which clearly also affected eye movement behavior. And to give you an idea of the strength of these, here are some sort of little scatter plots. The key problem here, of course, is that this was intended as an experimental study and it was not really powered for individual differences research. But given the intrigue of this finding, we definitely wanted to follow that up. So we moved on to our final study for this PhD, seeing how individuals prefer to use spatial attentional deployments. So given what we had just seen, we had two follow-up questions in mind. One of these is whether individuals have systematic preferences across different deployments of spatial attention. So are there some people who are really interested in the world around them, they're sort of bouncing around with their eyes everywhere, they use a big breadth of attention, they want to get as much information as the world has to offer. Conversely, are there some people who really don't explore very much, who stay within their little safe zone, who prefer a small breadth of attention, potentially more detail-oriented? We also wanted to know what factors might be associated with these preferences for behaviour. And what we did again, the methodology was very similar to study 3, except we removed load manipulation and increased the sample size to recognise that we were doing individual differences analyses here. We ran 2 experiments, each one of which tested a different set of potential correlate variables for our behaviours of interest. In the first experiment, we tested working memory capacity, which is basically how much information we can hold in working memory as a potential trait level analogue to our state level working memory effects we'd observed. We also then moved on to something a bit more left of field, but conceptually interesting, whether personality and world beliefs relate to our preferences for exploring the visual environment. Given that they exert such a strong influence in how we perceive and interact with the world around us, we wanted to see whether we could observe this even in really low-level behaviours. And here's what we found. Basically, there was no sort of relationship between individual preferences in attentional breadth and eye movement behaviour, so we don't have these systematic modes for exploring the world around us. However, when it came to predictors of behavioural preference, we saw no relationship with working memory capacity, but a remarkable relationship with openness to experience as the personality variable. And intriguingly, we saw that this negatively predicted eye movement behaviour, such that people with higher levels of openness to experience were associated with much less exploratory eye movement behaviour. So we think that there may be some kind of link here between different subfacets of openness, like aesthetic sensitivity and intellectual curiosity, people's preferred eye movement behaviours. Potentially people who are higher on openness might be more absorbed and engrossed in their processing of the visual world. So some key takeaways from this second part of the thesis. I think this demonstrates the flexibility of eye movement-based data, gives us this remarkable ability to observe both group level and individual differences effects within the same data set, which is something that's a major challenge for cognition at the moment. We saw some level of impact of working memory on eye movement behaviours, and we saw this interesting individual differences association with openness to experience. But really the most resounding, striking finding that's come out of this thesis is how robust individual differences in eye movement behaviour are. We all have these unique ways of physically exploring the world around us. So that brings us towards the end of the presentation now, where I want to offer some conclusions from this research. Firstly, why do these findings matter? Particularly given that some of them are quite technical, they're not necessarily the most exciting pulse-racing findings in the world. Well, one reason is methodological implications. Psychological science has undergone a lot of changes, even in the past 10 years alone, around things like measurement reliability and construct validity. And I think that these findings encourage us to take the time to question assumptions about how we measure the constructs which interest us. And only if we can validate them should we be really confident in what we're taking away about them. Secondly, these findings do have practical applications, particularly from the first part of the thesis, things like driver safety measurement and intervention. Given that the UFOV task is such a great predictor of crash risk in older adults, maybe can we trace that back to the source and see whether people's ability to resize their attentional breadth predicts crash risk outcomes? And finally, cross-disciplinary knowledge. Now, this is not something that I set out to incorporate in my PhD, but I'm really happy to have ended up here. It's given us a better understanding of how we as individuals interact with the visual world around us. And it's cool to see that we can bridge these basic and complex aspects of the human experience by observing relationships between personality, quite an abstract high-level variable, and something as basic and technical as eye movement behavior. In terms of future directions for this line of work, one of these I've already kind of discussed already. We can see whether the ability to resize attentional breadth predicts crash risk in older adults, but even if we can train people on it and see if that increases their efficiency as drivers, whether it reduces their crash risk by making them more efficient at working with information from the visual environment. Secondly, I think something that offers real promise from this thesis is about reliability in eye movement behavior. So the fact that we can simultaneously index experimental effects and reliable individual differences from the same data set is huge, gives us potential to adapt these existing experimental tasks from cognition, which notoriously have really poor individual differences reliability, see if they can be given a second life as eye movement behavioral measures. Finally, this relationship between eye movements and personality, one question we would definitely love to know more about is whether specific facets of openness to experience, like aesthetic sensitivity and curiosity, are responsible for this relationship. So in terms of next steps, where I'm taking this now, as Steph mentioned, I will be off to start a postdoc at UNSW in the not too distant future, starting in around mid-June. So that gives a very clear timeline for thesis completion. What I'm going to be doing there, I'm going to be applying some of the expertise that I've gained from this thesis, working with eye tracking and spatial deployments of attention to help us learn more about attentional control and its relationship with reward signals. So how does the prospect of reward modulate the way that we use spatial attention? I want to offer up a huge thank you to the ACT Government Road Safety Fund, who were really instrumental in funding some of this research. A huge thank you to my friends and colleagues at ANU who have kept me sane through some of the difficult times that anyone faces in a thesis, I think. And the biggest thanks of all to my supervisory panel, Steph, Mark, and Brad. You are awesome. You've kept me on track. You've supported me. You've taught me more than I could possibly have imagined I would learn. And I am so grateful to you for that. And that brings my presentation to an end. Thank you very much.
Yeah, so we have plenty of time for questions and discussion. Just Nick, just in case people online can't hear very well, if you could, I'll try to type as well into the chat. But I know we've already got some questions around. Maybe let's see online.
First of all, congratulations for being so close. You should also be confident in the fact that your research is interesting to people outside of cognition. I will say as someone nowhere near cognition, fascinating. I guess my question would be, so you were talking about how like personality could be, like personality traits could be predicting the way we have like eye movement and that like the profiles and like the individual differences. I was wondering, and this probably wouldn't be something you might have like researched, so you can just, using all the knowledge you have in your mind, make an educated guess.
Yeah.
But what about like the reverse, right? Like eye movement is something that what, like by 6 weeks old we can do. I don't know, I haven't done development like in ages. So it's something that we like learn as we grow from such a young age. And I wonder if how we like experience like the consequence of our eye movement, right, when we're young, whether that would then influence the traits that we end up developing. Like if someone is moving their eyes too much and they're finding that they're getting like a negative consequence, like it's overwhelming, they're seeing more than they would like, I wonder if then they would be less open to experience.
Yeah.
So then while people who didn't move a lot when they were younger didn't get like a negative reinforcement, so therefore they have more openness to experience. Anyway, you see what I'm trying to say, like the reverse relationship, ideas that you might have seen, bringing in all the knowledge you've ever learned. That's my common question, yeah.
Yeah, I mean, it's a fascinating question. It's one that was on my mind writing this presentation. For the audience, it was about the developmental implications of that relationship between eye movement, behavior, and personality. You know, the chicken and the egg problem of like, can we trace back a causative factor here, you know? Something that I will mention, which is tangential to that point, is that I think there's been a lot of research in recent times, not my area, don't come for me over this, about where personality comes from, why it remains stable or in a state of flux over time. And one of the things we looked at is this idea of primal world beliefs. That's a core set of beliefs about things like whether the world is a safe and an interesting and a sort of welcoming place. And we included those as measures in study 2, and we didn't find them to correlate. But we had that exact idea of interest there where we wanted to see if there was something that underlay that relationship between personality and eye movement behavior, something that offered a little more explanatory power for how that relationship came to exist. I agree with you, it's a fascinating topic. And like, for the developmental people in the room, by all means, please take on this research question. I mean, where would we be in developmental psych without the looking paradigm? But this idea that there is some kind of genesis, there's some sort of point at which that relationship emerges and some sort of causative direction there is really of interest to me. I wish I had answers for you, but all I can say is it's a great question and I am on board with you in wondering that.
No, that I like to ask questions that aren't always something that you've specifically studied, but more just hearing your opinion, because obviously you've gained so much knowledge over the time. Maybe one day when you're able to direct your own research and you're a fancy professor, you can figure out, you can email me, like, I got figured out the profile. Yeah, but again, well done.
Thank you so much.
But I suppose one suggestion, and
Yeah.
then an invitation for you to speculate. The suggestion is that if you're going to pursue the connection between openness to experience and preferences, you might want to look at a few other constructs that look like the next door, but actually can behave quite differently. One of them, obviously channeling my own PhD student, well, mindfulness is curiosity. There are different kinds of curiosity, and they operate in different ways, and they have rather different orientations towards things like openness to experience. Not all people are curious or open to experience, for example. The second one is that occurs to me is distractibility. Now, initially, I think that people are distracted, and that turns out not to be true. So, one possible explanation for what's going on with your relationship between openness to experience and potential focus is that these people who are open to experience may be less distracted than at least some people know. So if you look around for a measure of distractibility and get that into the mix,
Yeah, that's
then,
really.
then you might be able to start disentangling. Okay, and then the second, the thing I wanted to speculate about.
Yep.
If we think about as you have left over the line, about things like risk of event crash. Surely one of the explanatory factors in that is not what people are paying attention to, but what they're not attending.
100%.
I'm wondering what your line of research you think would have to contribute about theories of inattention, spatial inattention. What we miss?
Such a great question. Yeah, I was very fortunate to get invited early last year up to the University of Newcastle, where they're doing some research on this theme of driver inattention and why we miss what we miss at the moment. And it is such a fascinating topic of study. I think what I would say as a first response to that is that something which looms very large in our studies and Steph's work is this idea of attentional control, right? It's the idea that attention is not just this construct that exists in isolation. We're using it for different purposes. And along with that comes the idea that there's always a trade-off with attentional control. So you can be in a state of attentional control that benefits flexibility, so your ability to kind of take on board new information, but you can also be in a state of attentional control that really benefits persistence or continued focus on one goal or object. So I think that's something which is probably, I would suspect in a speculative kind of way, visible in eye movement behavior. So say that you're running a driving simulator study where you're sort of getting people to follow a car ahead of them and stay a constant distance from it. That's probably something where you would get a significant performance benefit on that task out of maintaining a very rigid state of attentional control where you maintain that goal focus. However, you would probably see a real lose out if like a car was to come from peripheral vision in that study, because you have compromised your flexibility by investing in that sort of persistent strategy. My real stretch here is that you might be able to see that in eye movements as well. I would imagine that you would engage in a lot less eye movement behavior when you were using a persistent strategy and a lot more when you were using a flexibility one. I think that it would be a really interesting thing to validate as an index of these different states of attentional control. And that might potentially explain to us more about inattention as well. So one of the biggest categories of road accident that concerns us in Australia is called look and fail to see. So for example, it's when you do a head check when you're driving and you've sort of done your due diligence, you've tried to see what's there, but you've just totally missed an object like a motorbike that's there in your peripheral vision. And I think a bit of information about attentional control states and whether you're kind of in that state of persistence or flexibility might help us understand much more about that genre of accident. Yeah. So thank you for the question. It's really interesting. I saw Steph was writing some notes on the suggestions earlier as well. So I'll have a peek at those after that. It's okay.
We have added time for some more questions for any in the room. Nothing online yet.
Of course, of course.
On the in the whole space, how do you know how big somebody's attentional breadth is? Like,
Oh, it's a really great question. I mean, it's one of those questions that sounds so simple, and then you think about it and you go, oh my gosh, the implications of this are so massive. One of the biggest problems with measuring attentional breadth is that it's really hard for us to know what kind of state of attentional breadth someone is in at every given state in time. So the way that we measure attentional breadth is largely stimulus dependent. It's saying we get someone to do this thing or look at this thing or attend to this specific region in space, and performance or neural correlates measures validate the fact that they are indeed doing what we think they're doing. What is really missing from the makeup in the attentional breadth literature is a measure that tells us what someone is doing at any given point in time in the same way as eye movements with their attentional breadth. It's that kind of latent behavioral index. It's not task dependent. It just tells us the state of attentional breadth someone is using. So in asking that, you've hit upon a really big issue, which is that that's super hard to measure. I mean, to my knowledge, there's just kind of like, that's almost an insurmountable difficulty for the attentional breadth literature right now. Yeah.
so it's like to do with the brain, or when you use it in your studies, was it that somebody saw something outside here and that's how you knew they had a big attentional breadth?
Exactly. So one of the things which would be, just hop out of this, nicest to kind of do with attentional breadth is to be able to move away from Nirvana figures. And don't get me wrong, I love my Nirvana figures. But the idea here is that when we run an experiment like this, we're basically using two attentional breadth conditions. One, we assume they have a breadth of attention that maps onto like the overall size. Here, we assume that they have an attentional breadth that maps onto that small component size. But we have no nuance. We don't know whether someone is sort of using an attentional breadth that's intermediate to those two things and not changing it. We have a lot of problems in how we assess specific states of attentional breadth. So we have to use these crude measures like this. And as we've discussed, we have that good neural correlates evidence that these ones at least do what we think they're doing. But it's one of the biggest problems that I can think of for this field overall. And it's definitely like general discussion material for the thesis as well.
Another question I have is, if somebody, like, I used to be a person that needed glasses but didn't have them, right?
Yeah.
So I think my attentional breadth was very big because it was very blurry. Could that be a thing? Because I think, like, say you were asked to look at the big cage, but you were kind of a little bit blind.
Yeah.
You wouldn't actually even see the eats. So is there anything about that to do with people's actual visual acuity, like whether they need glasses or something like that?
That's so interesting. I'm not aware of any research that has looked into that. But yeah, you can definitely see that people would use attentional breadth as like a compensatory mechanism for different kinds of like visual issue, you know. Like, for example, you can assume that someone who has quite poor sort of like short range vision would have to focus their attentional breadth so hard to get enough perceptual acuity to read fine detail or whatever. So I think even just sort of seeing the relationship between attentional breadth and people's ability on something like a classic eye chart would be so interesting for that reason. I have not thought of that before, but wow, this is why it's great to bring your research to a broader audience, people. Yeah, yeah, totally.
Yeah, fantastic presentation. So kind of following up on that, have you considered morphological changes that potentially so for instance, we know that as we age, we lose neuron function, we lose neuron and that can change attention. We know that's true these days. Is it possible that different people have almost a different point of view, which gives difference in
Yeah, I gotta say that's a little outside my area of expertise because we keep it pretty conceptual in cognition for the most part. We're interested in people's behavioral response. But that is
something.
Yeah, well, I mean, I can definitely tell you that there are analogous changes in the way that people use attentional breadth as they age. So people tend to prefer a narrower breadth of attention as they age, which perhaps indicates that they're not so good at expanding it out. Maybe they're losing, you know, particularly with that sort of peripheral density of rods and cones on the back of the retina. I imagine that would be harder hit than the foveal areas. I don't know that for sure.
The follow-on question to that is that we're now starting to see devices that bring function.
Yeah.
How do you see your work being related to how the interaction
Yeah, great question. I've thought about this a lot lately when I thought about my value proposition as a potential employee, I think the biggest one for me is actually user experience. It's this idea, one of the biggest literatures on eye tracking is not from cognition, it's from marketing. It's how to sort of use the physical features of like a web page layout to make certain features more salient to the observer. So I think for me, the sort of endless difficulty in experimental versus individual differences research is that in experimental research, we learn how performance as an average changes in response to a manipulation. But potentially a nuance that's missing from that UX side of things is how individuals respond differently to different sort of stimulus arrays and prompts. I know there's some groundbreaking research happening in Canada at the moment, for example, where they try and intervene with dyslexia by changing the physical layout of text on a page to optimize it for the individual's preferences. So I think that that will be a really fruitful route forward, potentially even using something like machine learning to optimize the way that information is displayed to you and make it as efficient as possible for your personal sort of eye movement strategies. Yeah. Thanks.
Yes, I have two questions.
Mhm.
The first one is with the Nav1 paradigm, you said it was like validated heavily. I was curious if it's been validated in like countries where their script isn't using our script. So like, has anyone actually made one, like, for example, I speak Arabic, so I'm thinking, I'm like imagining in my head how it would look. Have you come across anything like that?
Yeah, I'm not sure on cross-cultural validation of the Nirvana. That is super interesting. I can tell you that the Nirvana is often done with shapes, which should theoretically be neutral to that. But particularly with these letters, like we always collect anonymized demographic information in case there are different, like particularly we have a large mainland Chinese population that comes through our studies for whom this would potentially be an issue also. Yeah, you can definitely imagine that the sort of semantic salience of the letters would inform how people viewed and responded to them. I don't have info on that, but it's a really important proposition, I would imagine. Yeah.
I mean, because I'm thinking like, of course, English is like spoken pretty much all around the world at this point. So even if you're born in like a country that speaks like has a different like first main language, I guess, you would eventually have learned English in school. So it's not that people aren't aware, but I'm thinking like in Arabic, we connect our letters. And so their shape actually changes where they sit in like the word. And so I'm wondering if that would then, if we try to make like one using that, how that would look. But that's just a whole other thing.
Yeah.
My other question is if you could go to the slide where you show the difference between like attentional breadth and like this one where you keep like spatial facial movement. And it's like the two dots.
That one?
Yes.
Yeah.
So I was wondering if you've come across anything which would have more like accuracy, someone who goes from smaller to bigger versus someone who moves like with the second one. So it's like they've got small focus, obviously it's really clear, and they keep moving back and forth.
Yeah.
So kind of like comparing those two and whether one is end up being better, or is it like depending on the task that you need it for? Like I'm thinking someone who's like a taxi driver in London where they have to like zoom around all the different cars, like or like someone who's like the airport security and they're doing the like
the classic
so,
baggage.
I know
Again, dear to the heart of the cognition side. Yeah. Of course. Yes, sorry, I'm forgetting to do that. Okay, wonderful, thank you. The question here being, which one of these is a more efficient way to gather information from the world around you? So there is a level of context dependency there, like for example, when you're driving down the road, you probably don't want to break eye contact with the road unless you're doing it very briefly in like a planned movement. However, we would generally say that it's a lot more efficient to shift your eyes to different places in space. And the reason for that is morphological. It's the idea that the fovea, the sort of sweet spot of vision where we get the best acuity, is being moved to look at the point in space that we want to know the most about. So when we use a big attentional breadth over a large area of space, that definitely gives us information about what's happening there, but it has that loss of perceptual acuity that comes with it. And therefore, because we get a degraded percept by maintaining a sort of line of vision and altering attentional breadth outward, we would always prefer to move eyes if it was safe or sort of reasonable within task context to do so. Yeah. Yep.
What about focal length?
Yeah, right.
If you have attention to breadth of that, first of all, and then secondly, there's the kind of basic operation question. If I'm in a dense wood, I want to spot a landmark that's far away. I look at green leaves. and changing the overlaps together.
Yeah.
Is that been studied in context with either of your classrooms?
Say I'm not aware of that. I think attentional breadth has a history of being used in a way where it's not super well described as a construct, which has really affected our ability to study how it relates to perceptual mechanisms, where you just say like, oh, you know, something falls within someone's attentional breadth, or it's big or it's small or whatever. That doesn't give us a lot of nuance in terms of how it relates to focal length. Yeah, I would imagine for sure that was co-varying. It sort of gets back to even the eye chart or the eyesight question about how the dynamics of manipulating the physical bits that make up the eye relate to how we use attention. I know there's been some interesting research that's happening lately with pupillometry and attentional breadth, potentially using the size of the pupil to index the size of the attended region. That one's a bit of a fraught one just because there are so many other factors that influence pupil size, particularly light levels and even very minor changes to those. But I think it would be a fruitful line of study to know how those two things interact with each other. Yeah.
We've got a couple minutes, if there's maybe one last question break.
Yeah.
Yeah, I want to also lend my congratulations.
Thank you.
Of course, really fine set of studies, but an amazing speed at which with which you completed the PhD. So congratulations. And I want to echo Steph's comments about your contributions to the
Thank you very much.
question I have about the research is, as people have been talking, and I guess this is a bit related to my acceptance, considering this relationship between attentional breadth and openness. And I'm wondering if there are sort of general systems or broader kinds of concepts that could connect these a little bit. If we think about attentional breadth, you know, it's related a lot to sort of some general systems types of brain activity, right? So maybe volitional sort of brain areas that control volitional behavior a lot, even EEG coherence, other, you know, sort of other neural noise, cognitive load, all those types of things.
Yeah.
And openness has a kind of relationship like that too. It's well correlated with general intelligence, also again with the EEG coherence. So you think that both are tapping into some sort of general brain fitness. Aging is another one, but a general brain fitness or, you know, capacity or ability that's connecting them.
I mean, that's $1 million question, isn't it? It's this idea that, you know, there's this sort of core module of executive function or efficiency with which we can act in the world around us. I think for me, there are already a lot of definitional debates in my area about how to distinguish selective attention from executive function to start with. And I think it's one of those things that, like, sharing neural circuitry versus describing these things as qualitatively different becomes a very entangled problem to pull apart, right? Because for a long time, attention was viewed as unitary. It was much like executive function, viewed as this thing that you either apply or don't apply, you know? And only within the past 20 or 30 years have we really started to see the nuances of attention, its processes with a set of common goals rather than a set of common mechanisms come through. But I agree with you, there's compelling evidence, I think, that executive function, our ability to allocate attention and determine what is receiving attention and to maintain task focus during that process is likely to be related to those things. I know a lot less about the relationship between openness to experience and that more general function, but again, we will be reading in preparation for my general discussion. So thank you for that. Yeah, no worries.
Great. Well, that was fantastic discussion. Please join me around applause. And thanks to everyone online. So I have booked a table at Badger if anyone would like to join us for drinks. And of course, you're welcome to after if you've had any discussion planned for your panel. Next week, our seminar will be on Monday at Innovations Theatre. So please join us for that. And that is the end. So thanks.